The Southern Hemi awakes. I'm Mark Sponsor, and welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, April 14th.
Stormsurf, waves, weather, buoys, altimetry, snow, temperatures, El Nino, weather analysis, essential data for outdoor people, all the time, no hype.
Be sure and like and subscribe. If you like the video, give us a thumbs up. If to subscribe, just click the Stormsurf icon down in the lower right-hand corner of your screen. And if you'd like to make a donation, contribution to the cause, hit the special thanks button down below, the heart with the $sign in it. And with that, I'd like to thank the folks that donated last week. Our usual cast of longtime contributors, too. Our Predicament, Elliot Harris, Tim Caston, and Evolution Moto. Thank you so much for your contribution. I do appreciate it. And with that, let's get to work. We'll start by looking at significant wave heights for the North Pacific Ocean, and we do have, I wouldn't even call it a gale, more like a low pressure system, cut off low, northwest of Hawaii, generating up to 20-foot seas, almost aimed at the Hawaiian Islands. It's possible that some swell will result from that. But otherwise, little bit of remnant seas from a local gale, another backdoor trough, cut off low sort of thing off the coast of California, but it's really winding down now. And then some other seas associated with low pressure in the Northwest Pacific and of no real interest. So let's take a look at current conditions. We're going to start in Northern California, the Point Reyes buoy, number 029, off of Point Reyes, California. We're looking at all the energy that's hitting that buoy from all the way up to 33.3 second period, super long period energy, which there is none. And you see as you get down into the 25, 22, 20 second range, there is a little bit of energy hitting there, that from the Southern Hemi. But then the larger swell, you can see the peak right here at about, 9.9 seconds. That is local swell from the gale that was off California mainly yesterday. Put all this together, try to tease out what the primary swells are. Well, 5.9 feet at 10 seconds from 304 degrees, and then small swell 2.4 feet at 13.3 seconds from 221 degrees. I'm sorry. The primary swell here about making surf about head high, which is about what it was this morning. And then the secondary swell, the Southern Hemi swell, about waist high. And let's just see. Yeah, you can see it right in there. Not real obvious, but it's there. Then we go down to Southern California, the Point Loma South buoy off of San Diego. Again, same profile, but we see this big pulse of energy in the 13-second period range, another little pulse out here at 20 seconds, then some wind swell in the mix. Let's see if we can tease out what's going on. Primary swell, 4.5 feet at 13 seconds from 273 degrees. That is the local gale swell, along with secondary wind swell intermixed with that at 3.1 feet at 9.5 seconds from 290 degrees. Surf supposedly up to head high. I haven't really looked, but I did see there could be some waves pushing the head high range at select spots down south. But I almost think some of that is more Southern Hemi swell than Northwest Pacific or Northwestern swell. And then finally, we go over to the North Shore of Oahu, Waimea Bay. Again, same sort of profile, a little bump of energy at 16 seconds, and then really not a whole lot of anything else going on. Primary swell, 1.2 feet at 17.1 seconds from 325 degrees, so it's a little bit of northwest swell trying to slide in, but surf size, only 2 feet. That would be, maybe thigh high. And then wind swell, again from the northwest, 2.2 feet at 8.6 seconds, again in the 2-foot range, and not particularly interesting. All right, let's go back in time and see what's been going on in the North Pacific Ocean. This is the U.S. mainland here, Canada, Aleutian Islands, Japan, Hawaii down here. A little bit of a gale underneath the arrows here developed on Wednesday evening, the 10th of April. You can see here, I'll pull away from it so you can see it right there. 29.5 foot seas in the center of this thing, the highest seas over this entire domain. But you also see that it was aimed pretty much due south, not at the Hawaiian Islands. This would have been good for a rather large local swell, but no energy aimed at the islands, at least not as of Friday and even into Saturday. But here we are Sunday, and we're going to go back and look at the one off California. You see the gale starting to move, drift off to the east with 20-foot or 19, maybe 20-foot seas, starting to take aim at the Hawaiian Islands. Now, at the same time, we're going to go back here. We're going to go look off California. On Friday, a gale developed off the Pacific Northwest, falling south with 20-foot seas, not really aimed at the U.S. West Coast, and then sort of stalled and reorganized a little bit, pushing 17-foot seas on Saturday midday into central California, towards southern California as well. And that swell, as of right now, is hitting. Nothing huge, but there are rideable waves. And then we look down south, particularly under New Zealand here. A little gale developed on Saturday, a week ago, the 6th into the 7th of April, with 30 to 33.2 foot seas under New Zealand, pushing east, almost a little bit northeast, and then fading. Swell from this system is hitting the south shore of the Hawaiian Islands as we speak. We didn't go look at the buoys, but there is a little swell there. Not a whole lot. And this is bound for the U.S. West Coast. But it will probably be lost because another gale developed right behind that on Tuesday with 34 foot seas. Yeah, right at about 34-foot seas, but aim due north. Sideband swell from this system is pushing towards Hawaii, but probably more so towards the U.S. West Coast, sort of almost bypassing Chile and Peru. Central America should do okay, and Mexico as well. Probably the first semi-legit swell of the summer season. It seems like we are now transitioning away from winter and clearly into summer. Another system pushed Wednesday under New Zealand, trying to get some traction, but it fell southeast. It wasn't until Thursday, the 11th of April, that it really kind of got some traction. 41-foot seas and then 39-foot seas, pushing mainly off to the east into Friday night, but still some swell is expected from that. And then we go into Saturday. Things settled down a little bit. Oops. And there we are as of right now. All right, so let's take a look into the future. What is going on? We're going to do, again, we're sort of beating a dead horse here, but we're looking primarily at the northern Hemi. Yes, the southern Hemi is waking up. The north hasn't completely given up the ghost. There is some activity going on, so we'll focus on this. But I suspect either next week or the week after that, this is all going to be gone, and all our focus will be on the southern Hemi completely. So we'll start by looking at jet stream level winds. These winds up about 30,000 feet help support the formation of gales. When those gales form, help direct their track. We're looking for a trough, a dip in the jet, like there, and like there, and like there. That helps create a counterclockwise flow aloft because the winds in the jet move this way. So it's like creates an eddy in the upper atmosphere. Counterclockwise circulation, and down at the ocean surface, that's the hallmark of low pressure. And of course, if low pressure is strong enough, it generates seas. It gets traction on the ocean surface. And those seas eventually, the raw elements of those seas decay off, exposing swell, and swell and hits your beach, turns into surf. All right, so we have a series of troughs. The most obvious one is the one here north of Hawaii. This is as of this Sunday evening, the 14th, and we suspect that will help generate some swell for the islands. The trough that was previously off California, moving inland over Nevada now, and the other trough, notice the winds pushing down into it are pretty weak. This trough here north of Hawaii, let's see, it's pretty weak too. I mean, 90 knot winds, but there is a little pocket down here of almost 130 knot winds at the apex, the bottom of the trough. That's helping it get some traction. So we get into Monday and Tuesday, the trough pushes east of the Hawaiian Islands, pretty much fades out. And notice the jet is extremely split. southern branch sort of meandering along, northern branch waving around up here in between these dead air spots in between the two branches. That is typically high pressure. Another trough is forecast Wednesday, the 17th of April in the northwestern Gulf of Alaska, perhaps getting some traction. It is fairly pinched though, and then as you get into Friday, well, it pretty much just fades out, and you get this fully just completely split jet with the northern branch here, southern branch here, no, and a giant gap in between. That pretty much seals the deal for the end of winter, but still, little troughs are trying to form. But given the seasonal change, it just seems not highly likely that anything meaningful is going to result. All right, so let's go take a look down at the surface. This is surface level pressure, surface level winds. We know there's a trough here, a trough here, and a trough here. Sure enough, the only one that really is doing anything, the only trough that's providing any fetch of interest is the one north of Hawaii with 35 knot north winds. But you can sort of just follow the arrows. Hawaii is over here, maybe just the faintest bit of sideband energy targeting Hawaii. But as we get into Monday morning, well, the fetch fades 25 to 30 knots, but still that's good for wind swell pushing into Hawaii. And then that low completely fades out as we get into Tuesday. Models suggesting some sort of a gale low developing off Japan. Doesn't seem really likely. Of more interest, over the northwestern Gulf, Wednesday night into Thursday, the 18th, 30 knot northwest winds. Again, that's not even gale status, so nothing there. Theoretically, a legit gale as we get into Thursday and Friday, pushing off Japan with 45 knot winds. Ooh, I'll believe it when I see it. And then another gale developing even on Saturday, right south of the eastern Aleutians, but all fetch aimed due north and really not doing anything. And maybe a hint of another semi-cutoff low off the Pacific Northwest next weekend. But I don't know. It just seems like the North Pacific is fading. So what effect do those winds have on producing seas? Well, we have like 20-foot seas northwest of the Hawaiian Islands aimed south. As we get into Monday, we'll see if we can pull away here. There you go. A little tiny patch of 18-foot seas targeting the Hawaiian Islands. And then by the end of the day, Monday, it's in the 16 to 17 foot range, and then just fading from there. Wind swell likely for the Hawaiian Islands. Other than that, our next gale, well, look at this, actually theoretically 30-foot seas over the tiniest little area off Japan on Thursday, Friday. The gale up here in the Gulf, not looking, in fact, let's go back and look at this, because earlier runs of the model had 18, 19-foot seas up there. Now, not even that, 17-foot seas. So, and this one off Japan as we get into Friday, Saturday, the 20th of April, just not looking, not believable. Looks good. I don't believe it for a second. And then that's pretty much it. Now, the southern Hemi has been pretty prolific for the time of year. Let's see if it's going to keep up with all that goodness. As of Sunday, a little area of 26-foot seas lingering in the southeast Pacific, lifting northeast. Maybe that's good for some 14, 15-second period background energy pushing up into California. Another gale was forecast here on Tuesday, pushing under New Zealand, but it's just so tiny, and seas are like 34 feet. Not sure how much traction this is really going to get. We'll have to keep our eyes on that. And then it starts falling southeast and doing nothing. Another little low forecast off of Patagonia as we get into Thursday. But for the most part, all that energy, it's aimed north, but it's so far east of the Southern California swell window, which cuts off somewhere around 117. It's doubtful any southeast swell will result for even the most exposed breaks in Southern California. And then we just sort of run through this because after that, things kind of get quiet. We've been on a roll. Now, if this low develops a week from now under New Zealand, whoops, there we go. We'll see. I'll believe it when it happens. It doesn't seem believable at this point in time. Local wind forecast. Here is California. Here's Hawaii. Here, low pressure north of Hawaii. Actually, look at this, and you could almost go, yep, sure enough, some fetch you're looking at the actual wind barbs instead of the swell vectors from the wave models, it actually looks like Fetch is at least targeting Kauai and maybe sideband energy into Hawaii, into Oahu. So maybe something happening there. Along the California coast, a northeast wind pattern, pretty light, so not bad. Hawaii under the influence of southerly winds looking to turn westerly. We get into Monday, and there is that westerly flow for Hawaii. Northwest winds build for California, north of Point Conception at about 15 knots up to 20 knots off of Cape Mendocino. Pretty much the same thing on Tuesday for California, same thing for Hawaii on Tuesday. Wednesday, this looks like more like a standard summertime pressure gradient. That is high pressure here. Low pressure inland tightens up the isobars. You get a area of 25 knot north winds blowing down the coast, but makes it down about as far as Point Arena, and that's it, making wind swell down to Point Conception. But near shore, wind's not too bad in the 10, maybe 15 knot range. Hawaii, where is Hawaii here? Still under the influence of some sort of northerly wind. So we get into Thursday, same deal for California. Winds trying to turn northeast for Hawaii, but not quite making it. And then by Friday, more or less a light wind regime, no wind swell even for California. Southern hemiswell, though, possible, coming from that low that was down south in the central South Pacific. And trades finally return for the Hawaiian Islands. They're still with a pretty good north tilt on them. By Saturday, well, there you go. A light wind regime for California, sort of the same deal for Hawaii. And Sunday looks like high pressure starting to build. Northwest winds, 15 to 20 knots for California. Trades for the Hawaiian Islands. Precip forecast for California. This is as of Sunday afternoon. It's showing rain along central to North California area, but not even close, at least here in the San Francisco Bay Area. It's showing snow in the Sierra, but as of this morning, there had been only the faintest dusting, not even really measurable snow. So I say that is highly suspect. And then as you get into Monday, everything just dries up. High pressure sets up. We're going to blast through this because the suspicion is nary a drop of rain is expected for the rest of the season. So rainfall totals. This is the full season percent of normal here for, we'll say, most of Northern California. Between 90 and 100% in the San Francisco Bay Area, depending on where you look, but about 100%. The rain gauge here at about 110%. Then you get down into Central California, anywhere from maybe 85%, but most areas 110 to 130%. So in good shape there. Southern California takes the winner. Could you believe it? Earlier this season, I would not have thought that Southern California would probably max out, but solid at probably 150% of normal rainfall. That is great news. Surf forecasts we'll start in Ocean Beach, San Francisco area. Wave heights in the 5-foot range into Monday, sort of dropping off. Northwest wind swell, you can see the arrows down here. Sort of that same pattern continues. But as you get into Wednesday, you can't, that's the wind, sorry. Let's try that again. Right, surf spot forecast. We're going to look starting in Northern California, Ocean Beach, San Francisco. Northwest wind swell in the 4 to 5 foot range. Now you can't see it here, but Wednesday, when we get down, I think, to the swell forecast, you'll be able to see there's some southern hemiswell sneaking in underneath the actual wind swell here. And then slowly fading off. Notice winds picking up, though, as we get into the latter part of next weekend. Here is the actual swell size, is 5 feet at 8-9 seconds, and a little pulse southern, no, this is still northwest wind swell here. But here you go. You can see the southern hemiswell. It sneaks in little spots. 2 feet at 17 seconds on Wednesday, 1 feet at 19 seconds on Tuesday, and then it gets lost in the wind swell again until you get out into Friday in the 2 foot at 14 second range. But suffice it to say, some sort of southern hemiswell, and that's probably the more interesting of the swell starting late Tuesday the whole way through the week. Then we go down to Southern California. We're picking Dana Point here because at least this one, this graph is able to pick out the Southern Hemi swell a little bit better. Not a whole lot going on Monday into Tuesday, but then you see surf heights 3.5 to 4 feet, and you could expect bigger surf than that, add about another 25% on top of that at top spots that focus Southern Hemi swells, and basically it just hangs on the whole way through the week with relatively light winds. Swell sizes, here we go, 1.5 feet at 18 seconds on Tuesday, 2.5 feet at 16 to 17 seconds on Wednesday, 2.5 feet at 15 seconds on Thursday, and just holding on the whole way. And then another little pulse even as we get into Sunday in the 1.5 at 16 to 17 second range. So looking pretty good. And then finally, the North Shore of Oahu. Yeah, maybe I should have done the South Shore, but North Shore, theoretically, swell 10 feet or surf 10 feet. That's probably a little bit on the high side from the low north of the islands. That would be on Monday sometime, and then slowly fading from there. Trades, well, look at the winds north. You can look at the little arrows here. Some version of north and not really getting easterly until pretty much the swell is over. Let's go look here. 8 feet at 11 seconds, 8 feet at 12 seconds. Theoretically, that seems a little bit on the high side, but either way, there's something if you can find a protected spot to go surf at. All right, let's go take a look long term. What's going on with the MJO and the ENSO, the Madden-Julian Oscillation and the El Nino Southern Oscillation? The two major influencers that affect storm and swell production, both in the winter months, a little bit less of an influence in the summer, but still does have a positive influence. We're going to talk first about the MJO, the Madden-Julian Oscillation, a periodic weather oscillation that circulates around the planet from west to east on the equator. The active phase of the MJO on one side of the planet, inactive phase on the other. They rotate opposite each other around the planet. The active phase is like a low-pressure system. The inactive phase like a high-pressure system. The active phase is the good phase. When that moves over the Pacific, it takes warm, moist air that's down at the ocean's surface, lifts it aloft. That warm, moist air feeds into the jet stream, energizing the jet stream, and a stronger jet stream, of course, makes stronger troughs, which then in turn makes storms and surf. All right, so what happens when the active phase of the MJO moves over the Pacific? Because it's low pressure, it cuts into high pressure that's normally there that drives trades, and it reduces trade winds. So you can see it in this chart here. So this is data from the TAO buoy array, a series of buoys strung across the equator. That's the equator there. This is the East Pacific. This is the West Pacific. 180 degrees, that is the date line, that is New Guinea right there. We're just looking at the arrows. You see winds pretty strong out of the east, so those are trade winds over the East Pacific, pretty strong out of the east over the Central Pacific, same thing in the West Pacific. So no clear indicator of the active phase of the MJO, but it's really the anomalies. That's the thing that matters. And here you see the winds maybe just slightly stronger out of the east, kind of a neutral MJO, almost dead neutral over the dateline region. Same thing in the West Pacific. So not really a inactive phase, not really an active phase either, just kind of somewhere in between, at least according to this chart. Now, also note, though, these are 5-day average winds, so this is really more an indication of what was going on 2 or 3 days ago. And here's the pattern for the past 5 days. 850 millibar vector wind anomalies. The same thing. Is the wind blowing stronger out of the west or stronger out of the east than normal? If it's out of the east, that's blues here. That would be stronger trades. That'd be the inactive phase of the MJO. And it's only on the equator that matters. 5 degrees north and south. In fact, there's South America. So Chile, Peru, Ecuador, Central America there. New Guinea there, 0. That is the equator, date line right there. The real area where all the energy gets transported into the jet stream, be it either the northern Hemi or the southern Hemi, it's pretty much right here. We call it the Kelvin wave generation area, from about the date line on west to about 125 east. We see blues, easterly anomalies on April 8th, so that'd be the inactive phase of the MJO. Same thing on the 9th, the 10th, the 11th. But then we get to the 12th, and you see westerly anomalies starting to show up, like maybe the inactive phase of the MJO is weakening. That would be a good thing. Here is the past performance and the forecast for the next 2 weeks. This is from the GFS model. And let's get ourselves oriented here. So this is the blues are easterly anomalies, inactive phase of the MJO. The reds, westerly anomalies, the active phase. The date, this is for the whole planet though, all the oceans of the planet. So the date line's right up the middle. West Pacific starts at about 125 east, so right about there. You can almost see a seam in the colors right there. So that's our starting point, and pretty much it ends at 170 west. So you can see on March, the whole way through latter part of March and into April, easterly anomalies covering the Kelvin wave generation area. Today, a little pocket of westerly anomalies, but not really in the Kelvin wave generation area. Easterly anomalies supposed to continue, actually, and continue, and continue. So no real signs of an active phase of the MJO projected, just sort of a slightly inactive phase. Outgoing long wave radiation. This is just fancy words for cloud cover. If the active phase of the MJO is a low pressure system and it takes warm moist air at the ocean surface and lifts it aloft, well, that warm moist air, when it hits cold air above, will condense into clouds. So this is just an indicator of, are there more or less clouds than normal? Outgoing long wave radiation. So if you have sunlight, if you have a lot of clouds, sunlight can't radiate through the clouds, bounce off the ocean surface, and reflect back, outgoing long wave radiation. But if you have no clouds, then you got a lot of reflection off the ocean surface. Anyway, here we are. Here's South America, Central America, New Guinea, Hawaii, the equator right there, dateline right there, the important area right here. This is showing neither a blue or a yellow, red, orangey pattern, a neutral MJO. Continuing 5 days from now, continuing 10 days, and 15 days from now. This is a statistic model. The dynamic model, the GEFS model, pretty much shows the same thing with a tendency towards a weak active phase setting up 2 weeks from now. So we'll see. Let's dig in a little deeper. Phase diagrams for the same two models. The statistic model, the dynamic model. You can see this is in March 5th, where the active phase was. Oh, and how do you read this? Well, the MJO moves from west to east. You can see it plain as day here. From the maritime continent, you see it going here, over the West Pacific. So it was there on the 17th, the 18th of March, and then over the East Pacific, under the United States, across the Atlantic, over Africa, where it was on the 24th of March. And then here we are in April. It's weaseling its way through the Indian Ocean and pretty much crashing. If the dots are inside this circle, then the MJO is considered to be extremely weak. The heavy dot right here is where the active phase is right now. So over the maritime continent, extremely weak. Forecast moving to the West Pacific, and again, so weak to not even be meaningful. That's pretty typical. I mean, the MJO is strongest during the fall and winter months. That's not to say it can't be strong in the summer, but right now it certainly isn't. This is the dynamic model here, basically painting the same picture. So a very, very weak MJO pattern forecast for the next 2 weeks. The upper level model, this is a statistic model showing areas favorable for precipitation. The green is wet air. The orange is dry air. So the green would be active phase of the MJO. Orange is the inactive phase. Let's get ourselves, this goes out 40 days, by the way. This is South America, Central America, New Guinea, equator right there, dateline right there. So supposedly now a weak active phase in control through about the 18th of April, maybe to the 24th, then moving off as the inactive phase comes in and makes its way across the Pacific into about the mid-May, and then another very weak active phase starts to traverse the Pacific from May 14th through about the 24th, and then the model ends. And finally, the CFS model. This goes out a month, 30 days. This shows, okay, and let's get ourselves oriented. Dateline, oh, pull it right here. There we go. Dateline right there. Far west Pacific right about there. So the important area is up from there to about there. This shows the actual MJO, the black contour. If it's dotted, it's in active phase, and you can see how dotted with blue means easterly anomalies. Solid contour, active phase with the reds, westerly anomalies. So this is back January, February, late February into March, inactive phase. Early March into about the end of March, active phase of the MJO. And then since about mid to late March, we've had easterly anomalies. There's a little sign of a weak inactive phase, but basically a very weak MJO pattern, at least the way this model, this picture is scaled from the CFS model, and easterly anomalies. And the forecast for the next 4 weeks shows easterly anomalies, no sign of the active phase. Now, this is interesting. We're going to go look at one more model. Same model, though. This is the CFS model, but going out 3 months. Forecast is up here. What's happened in the past is down here. This is, again, zonal wind anomalies. The date line runs right up the middle. The West Pacific, the all-important Kelvin wave generation area, starting about 125 east. So this is the past down here. You see westerly anomalies. That's probably the active phase back in December. Another active phase in January into February. Another active phase March. And then here we are today with blues and sort of interspersed other neutral to light westerly anomalies, but basically inactive phase. And then according to this, it looks like westerly anomalies continuing from, we'll say a week and a half from now, the whole way to the end of the model run, but that doesn't seem believable at all. All right, let's overlay the MJO. Now, this model's scaled a little bit differently, so it sort of amplifies anything that even remotely smells like an MJO. So here, the dotted contour is our inactive MJO. It says we're in the inactive right now. The other models showed basically nothing, a neutral pattern, but this seems actually more accurate. A weak active phase is forecast moving into the Kelvin wave generation area, 125 east, starting in the next 3 or 4 days, traversing the Kelvin wave generation area into about May 8th, so maybe 3-4 weeks, something like that, with weak westerly anomalies, and even weaker inactive phase to follow with those westerly anomalies holding over the date line, and then an even weaker active phase after that in June into early July with westerly anomalies. But notice the westerly anomalies are like almost retrograding and barely in the Pacific Ocean, so 125 east, that's New Guinea. Most of this is now over the maritime continent as we get into July. Not unexpected if you were having a La Nina developed. So let's overlay the low pass filter here, the low pressure, high pressure bias. Solid contour is the low pressure bias with 1, 2, 3, 4 contours. This was back in December. Clear El Nino signal, but dropping to 3 contours to 2 contours about 3 days ago. The very last contour, the last sense of El Nino in the atmosphere fading out about May 16th. And then notice the low pressure bias just goes flop and flops over into the maritime continent and starts building with 2 contour lines as we get into June. Also notice a high pressure bias starting to set up here over the Pacific. Notice the easterly anomalies associated with the high pressure bias. This looks like La Nina with what was the El Nino low pressure pattern moving out of the Pacific and into the Indian Ocean or maritime continent. All right, so what's going on in the ocean? There is an atmospheric component to El Nino in the MJO, but for El Nino and La Nina, there is even more so. It's the atmosphere acting on the ocean, and it is that signal in the ocean that really defines, is the foundation of El Nino or La Nina. So this is data from the TAO buoy array, those buoys strung across the equator in the Pacific, East Pacific here, West Pacific here. These are the anchor lines, these little X's here, and the X's are the individual sensors on the anchor lines. And with that data, and use a model to fill in the gaps, you get a profile of what the water temperature is subsurface. We're looking for Kelvin waves, or we're looking for, is warm water balled up more in the West Pacific or in the East Pacific? During El Nino, it tends to all be over here. During La Nina, tends to be over here. Pretty obvious pattern right here. The 29 degrees centigrade isotherm starts at 179 west and is slowly trying to make it, pushing even further to the west. 28 degree isotherm, very, very shallow in the east and bigger in the west. 24 degree isotherm, basically the same pattern. So not a whole lot of warm water in the east, most warm water at depth in the west. But it's not the actual temperatures. It is the anomalies, the difference from normal for this time of year. This really paints the picture. You see our thin little layer of 1 or 2 degree above normal warm temperatures here in the east, but what we do see that's more startling is 1, 2, 3, 4, 5, maybe even 6 degree below normal temperatures, pushing this way. A cold water, they call it an upwelling Kelvin wave. It's just not a warm Kelvin wave, a cold Kelvin wave. It will eventually breach the surface here, start upwelling to the surface, and then the trades will catch that cold water and drag it the whole way across the Pacific, and that will then start changing the atmosphere above it. Cold water does not promote evaporation. High pressure builds on top of it. That then in turn starts feeding the trades, and then that changes the cycle. El Nino was about warm water, like balls of warm water, Kelvin waves pushing across the Pacific, driven by the multiple active phases of the MJO, transferring warm water from west to east. Now we're in the opposite cycle. Warm water moving to the west, cold water backfilling in its place. All right, let's go look at another model. This one actually, it shows the same thing, but it shows the cold water, instead of being balled up back here, actually it erupting to the surface already. So interesting. This is a mixture of the same TAO data, buoy data that we saw before, plus satellite data overlaid on top of it. And you see literally no warm water in the east at all of it moving off to the west. This is the satellite data used in conjunction to build the previous chart. These are not temperatures. This is the height of the sphere of the ocean. Is this ocean surface, if you strip out the waves, the wind waves, even the tides, is it higher or lower than normal? Why does that matter? Well, if you have cold water at depth, it contracts. That will take the water above it and displace it and make a dip, and you'll get negative anomalies. If you have warm water at depth, it expands, it displaces the water above it up, and you get a positive bump. But let's get ourselves oriented here. Equator, dateline, Ecuador right there, the Galapagos there. This is South America, Chile, Peru, Ecuador. Central America, Hawaii is up here somewhere, and New Guinea over here. We see negative -5, -10, -15, and it's just 5 degrees north and south of the equator. We also see -15, almost 20 centimeter anomalies here. All this suggests is cold water from Ecuador over the Galapagos, the whole way out to the dateline and beyond, basically filling the entire equatorial Pacific. And it's really interesting that a little strip 5 degrees north and south of the equator, and temperatures changing 2 or 3 degrees can make the difference between El Nino and La Nina and change the global weather pattern in the jet stream, but that's all it takes. And what's even more amazing is we have the tech to be able to see it, monitor it real time, and talk about it here on YouTube. All right, let's keep going. Upper ocean heat anomalies over time. All right, West Pacific here, East Pacific here. You can see this picture real clear. This back May of 23, you see the oranges and red warm water being transported from the West Pacific to the East Pacific in the form of Kelvin waves, like right there. Another finger reaching across, another one here. At least one, if not 2, if not 3 here, and this was January of this year, so just a couple months ago. Then all of a sudden, there was no more warm water in the West Pacific to transport east, so then that's the end of it. Cold water here, it starts following the same path, so it's on its way. And we'll see whether it is erupting yet, but either way, subsurface, there's a massive reservoir of colder than normal water waiting for its opportunity to erupt to the surface. All right, so we've talked down in the ocean. We've even talked about the atmosphere and the forces, the atmospheric forces driving the changes in water temperatures. But at the end of the day, it's what's happening at the ocean surface and how does it affect evaporation, because that's what drives the cloud patterns over the Pacific, and that's what also drives the jet stream. So all this reinforces itself from up at the highest levels of the atmosphere, down at the ocean surface where wind blows on the ocean surface, down 150 meters into the ocean, and the whole stack lines up like during El Nino or at the peak of La Nina. But right now we are in a transition. So here is sea surface temperature anomalies. Difference from normal for this time of year. South America with Chile, Peru, Ecuador, Central America, Hawaii out here, and the equator roughly in the middle. Galapagos right there. So we see pretty much the normal cooler water along the coast of Peru up into Ecuador and even off of Ecuador. But now you see this long finger of cool water, cooler than normal water, starting to appear in a thin stream along the equator, while at the same time you have warmer temperatures north and south of it. The remains of El Nino, but you can also see warm water starting to, it's literally being pushed by trades that are building here, causing the upwelling, tapping that cold water pool, pushing warm water off to the west, setting us up for the development of La Nina. It isn't there yet, but this is the strongest sign we've seen yet of the cool subsurface pool trying to make its way to the surface. Here is the sea surface temperature trend for the past 7 days, and you see water temperatures are getting cooler. It was actually worse about 2 days ago. There's actually some pockets of warming here now. But in general, this whole area out to the date line is getting cooler. Also notice cooler temperatures down here in the South Pacific too. Not sure what that means yet. I mean, it's just a cooling trend. That could just be as easy or as simple as, yeah, we've had a couple of storms push through here that have generated swell, southern hemi swell, and so that creates mixing of the surface layers and deeper layers, and you just get a cooler pattern. And then the backed off view, sea surface temperature anomalies. Again, here is the leftovers, just 5 degrees north and south of the equator. Warm temperatures on the equator, but the beginnings of our La Nina signal here. And again, the big concern about how warm temperatures are here in the main development region, the MDR, where hurricanes, tropical waves pushing off Africa, we talk about evaporation, its influence on developing storms. A giant pool of latent heat energy to feed developing tropical systems. We'll see how that plays out. Again, that alone does not guarantee a hurricane season. Upper level winds and shear coming off the Pacific over the Atlantic plays a big difference, along with a whole host of other things. But for right now, something definitely to keep your eye on, especially if you live in the Atlantic, east coast of the United States or the Caribbean islands. Sea surface temperature trend in the Nino 1.2 region. This is the area right there by the Galapagos in Ecuador. Temperatures were falling precipitously with the upwelling of cool water, but then we notice a couple of warm pockets starting to show, and that's reflected here. Temperatures 188 thousandths of a degree, 0.2 of a degree below normal, so pretty much neutral, but you can see we were warmer and much warmer off the end of the chart here. But the official El Nino monitoring region here, the Nino 3.4 region, this is the area on the equator, 5 degrees north and south of the equator, from points south of California, 120 west, out to about the dateline, 170 west. Temperatures slowly working their way down, half a degree, 556 thousandths of a degree above normal, still in El Nino territory, but as that cool water upwells, it will continue to cut into this warm pool that at some point will be down at neutral. The question is, when? Sea surface temperature anomaly history, East Pacific here, West Pacific here. The reds and oranges warmer than normal temperatures. You see back in, what is that, June, May, April, a year ago, the beginnings of our upwelling Kelvin waves off of Ecuador, the building of the warm pool in the East Pacific, and then eventually filling the Nino 3.4 region right here in around Thanksgiving through Christmas and New Year's and a little bit beyond. But now you see the emergence of a cool pocket. You see the steady decay of temperatures here. Again, the official El Nino region from 120 out to 170, so right in here. So there's, what do we got? 1, 2, 3 shades. 1, 2, 3. 1 to, really? 1, 2, yep. 1 to 1.5 degree temperatures above normal, but that's probably, it goes out to here, so there's only some half to 1 degree temperatures in here. So again, you see the decay of the warm pool. So what does the atmosphere above the ocean think is going on? Well, we look at the Southern Oscillation Index, the difference in pressure between Darwin, Australia in the Indian Ocean and Tahiti in the Pacific. When pressure is lower over Tahiti, the index goes negative. So today, we're at minus 4.69, but this is a daily view is very noisy. You see it jumping all around. This can be influenced by, just a little local low pressure system moving over Tahiti or a little local high pressure system over Darwin. So you can see the trend still hasn't really, we had a couple of, maybe a week of double-digit negatives, but other than that, been hovering around zero. The 30-day average here is probably a better way to look at it. It takes some of the noise out. You can see the effects of the MJO on the 30-day average, minus 4.53. So we're actually dropping some here the past week or so. I think that is a lot influenced by this low pressure event that happened last week and part of the week before that. But prior to that, 1.4, you see, we're just hovering right around zero. I suspect this is going to go back to zero pretty quickly. The 90-day average, it's sort of a look back, a month and a half, minus 5.92. And basically, between minus 2 to minus 5, if we were still coming off a really solid El Nino, one would think this would be lower than it is. The fact that it's falling is kind of interesting. One would think, if anything, it would be rising, but I'd say give it about another month or two and you're going to see this steadily heading up. Let's go look at a graph of this data. So here we go. This is the zero line here. Positive numbers represent La Nina. Negative numbers, El Nino. So our big La Nina back in 22, you can see it here with numbers up in the 20 to 25 range. And then January of 2023 was the onset of El Nino. But then when we truly got into El Nino in the fall of 2023, we thought these numbers would be bouncing down hard down in here. But no, they kind of already gave up the ghost and just not nearly as strong as forecast. You kind of get the sense, though, that there is a upward trend. We're at neutral now, and we're heading back somewhere in this range. The question is how far and for how long. So here's a projection from one model. Here's the more the wild version of the CFS version 2 model. Sea surface temperatures, we were up at 2 degrees above normal. Strong El Nino bordering on super El Nino. I say that sort of with a wink, though, because one reading, you need months of that, and we weren't there. Anyway, today we are in mid-April, temperatures at 1 degree above normal, and the model has it crashing well into minus 1 degree by July and down to minus 2 degrees in November or so. Now, this is the more wild version of this model. The PDF corrected here says temperatures only going down to maybe 1.5 degrees. And last week, right there, and last couple of weeks ago when we looked at the consensus model, when it updated, it said temperatures only going down to minus 1. The consensus model, it's a sum of all the El Nino models. I think there's like 30 of them. It'll update again hopefully next Sunday. It might not be till Monday. but we're going to be looking at that very closely. The big rub is, we're in spring. They call it the spring unpredictability barrier. The models have a real hard time when you're in this transition from winter to summer, and they're not really sure where everything is going to go, so they give unreliable results. We get out of the spring unpredictability barrier around June 1st, and I think that's when we'll have a much better handle on at least the initial first year of this, what we assume is a pending La Nina. So for right now, a little bit of northwest wind swell or northerly wind swell for Hawaii expected, and we have some in the water for California, nothing really epic. Of more interest was a series of gales, one passed under New Zealand, but the better of the two was the one that formed in the south central Pacific last Tuesday, Wednesday, with 34-foot seas, aimed due north, unshadowed, targeting California with sideband energy into Hawaii. That will make for a good run of a couple of days of swell. And then there's been some other New Zealandish type activity going across the south central Pacific to add yet more swell in behind that. So it definitely looks like a summer swell pattern is setting up, though the North Pacific hasn't quite shut down. So a little bit of yin and yang going on here. But the good news is there is going to be surf. Long term, looks like we're heading towards La Nina. Details still to be determined. We got to get out of spring first. And really, this past weekend, at least in California, it was more like winter. There was snow on some of the peaks in the Bay Area, like for a day, half a day or something like that, and not much snow, but probably the last blast of cold air. After this, it looks like high pressure is going to set up. Rainfall totals looking good, reservoirs looking good for California. That's a plus. If we can get one more year of rain, and that is not out of the question. Typically, the winter after a strong El Nino, so that'd be this coming December, January, February, there's still latent moisture in the atmosphere from El Nino and also from the Tonga volcano. A couple of years ago, that might set up, with cold air from La Nina, might set up another good snowfall season. Rainfall, maybe not so much, but snow will take it. But after that, I suspect we're moving back into another couple of year drought period. So take what you can get while you can, and be smart with your water. Don't abuse it. Other than that, it looks like we are moving towards summer. If you enjoyed the video, give us a thumbs up. If you have any questions, write them up in the comments section. We'd be happy to answer. To subscribe, click the Stormsurf icon down in the lower right-hand corner of your screen. If you'd like to make a small donation, you can. Use the special thanks button down below. And other than that, we will do this again next week. Same time, same channel. Thanks for watching.